In this video, we are going to finish stamp number 3, doing problems 29 through 31. Number 29 says, write an exponential function of the form y is equal to ab to the x, whose graph passes through the points 0, 5, and 115. So in this case, when we did these problems earlier this year, we look at the higher x value, all right, and we want to plug that in first. So this is our x and y, all right. We want to plug it into the exponential function form, all right. So we go 15 is equal to ab to the first. Right underneath, we want to plug in the lower of the x values, all right. In this case, that's 5, because that's the y. Is equal to AB to the 0 power. All right. Now, anything to the 0 power is equal to what, guys? 1. All right. So we can just get rid of that. All right. That doesn't always work for these problems, but it works for this one. All right. And from here, it's exponential. We want to divide both of these values. 15 over 5 is equal to 3. The a's cancel. And we just have b is equal to 3. All right. In the past, we circled b. All right. And then we plug it back in to one of the equations. In this case, the top equation. We plug it back in. All right. We get 15 is equal to a times 3. Divide both sides by 3. And we get a is equal to 5. All right. From there, we can write our equation. Y is equal to our a value, 5, times 3 to the x. Done. All right, problem number 30. We're going to start problem number 30, which says, based on the patterns of change, which type of function best fits the data? Linear, quadratic, radical, exponential, or logarithmic. All right, we want to start these problems by trying to get some zero factors here, some zero x's, or find out what the pattern would be if x was equal to 0 for some of these, and it's going to help us to get our equations by hand if we have to get our equations. All right, so 5, 4, 3, 2, 1, 0. All right, if we look at what we're doing going this way, we are multiplying by 4 each time. You can check that. All right, and our y value, our f of x value. So if I divide, to the right, I'm multiplying by 4. To the as I go to the left, I'm dividing by 4. So this value would be 0, 1. All right. Again, 1, 2, 3, 4, 5. Well, if I go this direction, this value would be 0. All right. As I go, this is 15, 20, 25, 30, 35. I am adding 5 each time. All right, adding 5 each time. All right, I can see that. If I subtract 5, this would be 0, 10. All right, now, next one. Well, the increasing by 1 is in my y's, but it looks like 2, 4, 8. Not 2, 4, 6, but 2, 4, 8, 16, 32. So it looks like I'm multiplying by 2, or you could say you're doubling in my x's for this one. All right. So if I do that, this would be 0 in my f of x. All right. And it would be, if I'm multiplying as I go to the right, I divide by, and that would be 1. All right, so we got 1, 0 for this one. All right, now we kind of figured out the pattern for everything that we're doing so far. Let's just continue to figure out the pattern. So 0, 1, 2, 3, 4. Looks like we're adding 1. All right, like we were adding 1 here. All right, and adding 1 here, and adding 1 here. All right, and in my f of x, 1. 0 to 1, 1 to 4, 4 to 9. All right, so let's see. In this case, I would be adding 1, adding 3, adding 5, adding 7. All right, and so we're doing our finite differences, and we see we don't get it. All right, so earlier this this year when you did finite differences, if the numbers weren't the same or you couldn't figure out the multiplicative constant rate of change, then you kept going. So 1 to 3 would be plus 2, plus 2, plus 2. All right. So what this became is a second degree. All right. Constant rate of change. We'll go over that in a second. All right. Here, still 0, 1, 2, 3, 4. 400 to 200, 200 to 100, 100 to 50, 50. Looks like we're multiplying by 1/2. All right, each time. All right. And then the last one, 0, 4, 0, 4, 9, 16, 25. All right. Look at my x values in relation to my y values. What's going on here? Let's put a 1, 1. I think that there probably should have been a 1, 1 as a value in this problem, if I had to guess. Usually that would be a 1, 1 there. That would make more sense to the pattern. 0, 1, 2, 3, 4, 5. And then we got 1, 2 squares this, 3 squares this, 4 squares this, 5 squares this. All right. And so we can kind of see a pattern in our x's and our y. So let's go back to that. All right. Now we'll come back to that one. All right. Now in this case, for the first one, we want to be able to, first of all, tell what type of pattern is going on. And there we are multiplying by a constant rate of change, multiplying by a constant rate in our x's. Multiplying constant in x's. In our y. All right, and so we knew that one would make this exponential. Now, to find the equation, if we know it's exponential, we can go y is equal to ab to the x and see if we can get it. We should be able to get it in this case. All right, let's see. We know our initial value is 0, something. So it would be y is equal to, 0, 1. That's why we want to go back and find that value. And then b is our rate of change. In this case, we're multiplying by what in our y's? 4 to the x. No need for linear regression for this problem. All right, so there's your number 1. Bullet 1 is exponential. Bullet 2, y is equal to 1 times 4 to the x. Or you could just write 4 to the x. All right, y is equal to 4 to the x. All right, next one. All right, there is a additive constant rate of change in your x's. All right, does everyone see that? We're going plus 5, plus 5, plus 5, and then the f of x's, and plus 1, plus 1, plus 1 in the x's. All right, so we have a constant rate of change in your x's and y's, first degree. All right, that lets us know that this one is linear. All right, now if we're dealing with something linear, just like we had an equation for exponential, we can go y is equal to mx plus b. All right, and this is pulling back some Algebra 1 stuff. All right, for this problem, 1, 2, 3, 4, 5. I don't want to spend a lot of time with this because I still have never seen the linear one on the Algebra 2 final. Not saying that it can't be there this year, but I don't remember ever seeing it. All right, it's usually an exponential graph or a logarithmic graph. All right, because you've had this in an Algebra 1 class before, or maybe a pre-algebra class. All right, so in this case, if you remember, and like I said, this isn't a big thing because it probably isn't. This probably won't be the one on your test. We're going plus 5, plus 5. Whoa, running out of ink here. All right, plus 5, plus 5. All right, plus 5, plus 5. So in your, and we have that 0, 10 value. All right, because that becomes important. All right, you have, so this is, your slope is your rate of change. You're changing y over your change in x. If you remember, I don't want to spend too much time on this one. All right, so it becomes 5 over 1, which is 5. All right, and then your slope is, your slope is 5, and your y-intercept is whatever your y value is when x is equal to 0. So for this one, your function is y is equal to 5x plus 10. All right, the next one, and I think I'm just gonna move this sheet out of the way so we can make these tables real quick. All right, the next one is, can't even, it's not on. All right, is 2, 4, 8, 16, 32. All right, we're going to get that 0 value, 1, 0, and 1, 2, 3, 4, 5. All right, what are we doing? How can we explain what's going on in our table? All right, well, let's see. We said we were multiplying by 2 each time in our x values. All right, in our x values. So that's the inverse of an exponential. And what's the inverse of an exponential? A logarithmic function. All right, and if that's the case, our log is, well, in order to do our log, we usually find out what our exponential is and we flip it. But we're going to make this easy this time. We're going to say that for the problems that we're going to do, it's going to be y is equal to log times whatever we're multiplying by to the x. All right, that's how the problem is going to be on the final, if I had to guess. All right, and so what are we multiplying by every time? By 2. So your function is going to be y is equal to log base 2 of x. All right, and that's the kind of a shortcut for what we're doing. All right, next problem. In this case, we have f of x. All right, and they give you quite a bit of these, and it's a lot like the Montgomery County page worksheet that we did. All right, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. All right, so here's the thing. I got a question for you. All right, we're going to keep this simple. All right, earlier we said that there was a second degree constant rate of change, plus 1, plus 3, plus 5, plus 7, and then this was plus 2, plus 2, plus 2. All right, now, so that means that it's a second degree, all right, ROC, we say constant rate of change or rate of change. All right, and in that case, we learned earlier this year that it was going to be a quadratic. Now, let's think of an easier way we can look at this. All right, if my input is 0, my output is 0. My input is 1, my output is 1. It really doesn't tell us anything. All right, my input is 2, but my output is 4. My input is 3, my output is 9. My input is 4, my output is 16. What's going on? My input was 5, well, 25. What am I doing every time? I'm taking this number and doing what? Squaring it. So I can say y will be equal to, or f of x will be equal to, if I plug in an x value, I'm going to take that x value and square it. It's that simple. All right. Keep it going, and I'm going to have to erase though. Could have used another board, but I didn't. All right, are we at the end? All right, we're here, 0, 400, 200, 100, 50. You already see what's going on, all right? You should see what's going on in your y values. We're taking what every time? We're taking half, multiplying by 1/2. So we're multiplying in our y values every time, all right? That lets us know that it's exponential. All right, now, it being exponential, all right, we want to go to, once again, y is equal to ab to the x, all right? We already know what 0 is, all right? 0 comma 400, so that's our initial value, all right? Y is equal to 400, all right, times whatever you're multiplying in your y's every time. Yep, 1/2 to the x. Done. All right, and then the last one. All right, we're going to use it. We're going to look at it, and we'll notice that it's none of the ones that we really spent time doing. All right, we got 0, 0, and it doesn't help that they left out that 1, 1, but they did leave out the 1, 1. All right, 0, 0. I'm inputting 4. I'm outputting 2. I'm inputting 9. I'm outputting 3. I'm inputting 16. I'm outputting 4. I'm inputting 25, and I'm outputting 5. So when you look at the fourth one and the sixth one, look at them. They're very similar. All right, it's just a flip-flop. So for the one that was number 4, we said it was y is equal to x squared. We were squaring it. But in this case, we're taking the number and we are what? Taking the square root. All right? Which makes it a radical. All right? And the radical is y is equal to, well, we're taking x and we're taking the square root of it. So if I plugged 4 into the square root of 4, it's 2. Square root of 9 is 3, and so on. All right? And we're done. All right, problem number 31. All right, a rumor is spreading through a city that aliens from Mars will arrive tomorrow. The number of people who have heard the rumor, P of T, is a function of the number of minutes since the rumor started, T, represented by the table of values below. So let's take those table of values. 0, 1, 2, 3 minutes, 4 minutes. That's time, minutes. All right, 2 people heard initially, then 6 people heard, then minute 2, 18, 54, and 162. All right, so look and figure out what's going on. It's a quick pattern. Now, let me tell you something about all the tables you'll get on this final. They will either be logarithmic tables or exponential tables. You won't get a quadratic or a linear table usually, because those are units that are covered somewhere else. We cover logs, we cover exponentials, and so you can expect one of those on the test. All right, now in this case we're going I hope you're listening to me, times 3 times 3. I can see that. Well, you can check that, make sure it's right. I think it's times 3. And this one's times 3. So we have a multiplication problem. This is, an exponential problem. All right. This is exponential. So it says what type of function best models this, and it is exponential because of the multiplicative constant rate of change. All right, multiplying in your y's or your P of T's. Right, it says write a function that models this data. Well, we don't have to zero back because we know what 0 to, we know the initial value. So let's go back to our y is equal to a times b to the x. All right, a for this case is, well, 2 people heard the rumor. All right, and every minute the amount of people knew tripled, times 3 to the x. Questions? Because that's it for that part. All right, now it shouldn't be x, I'm sorry, and I shouldn't be y. Let's do it correctly. All right, I'll keep that up there. All right, and we should have P of T is equal to 2 times 3t to the t. All right. Now, the last question says, predict how many people will have heard the rumor after 9 minutes. All right, so we're saying that time is going to be 9 minutes. All right, we plug t in. So we're saying p of 9 is equal to 2 times 3 to the 9th power. So after 9 minutes, this is how quickly the rumors get around. Plugging in the calculator, 39,366 people will have heard the rumor. Done.